Alexander, hi.
Hi there, how are you?
I'm good. How are you? Kiev is on the line.
Yeah, I'm good as well. Greetings from Germany.
Thank you very much. How are things going in Germany?
Well, it's getting cold here, but I suppose Ukraine is always colder than Germany, so I
Oh
suppose I'm
no,
fine.
it's this is a stereotype. You should visit sometime Ukraine. Okay, I
Absolutely.
heard I heard that you are fond of a basketball. You are a basketball player.
Yeah, it used to be, but with age and kids, sometimes people become more of a basketball watcher than a player.
Okay, all right. Are you ready to have a talk?
Yes, absolutely.
Then the floor is yours.
Awesome. Thank you. All right. So, welcome everyone. Thanks for checking by. And today's topic is more about search and search in general. Of course, obviously, you might have guessed it. Working for Elastic means that I'm biased regarding my choice of a search engine, but I rather want to talk about relevancy because everyone knows that any application should have a search bar and it should be easy to use and intuitive to anyone who is supposed to use it. But the hard work in the background is the one that is important, like writing the correct queries, understanding the intent of the user, and also thinking about your business and maybe making your queries more to support your own business. And I've brought up a couple of examples that I just want to go through. I also brought the demo application. It's on GitHub. I will share it after the talk. You can check out things yourself, understand how queries work, how you can influence search. And the main metric here, or the main thing I want to talk about is basically relevancy, which means how can we write queries that return content that is as relevant as possible for the user searching the search engine. And yeah, that's our today's goal, right? Like I want to talk about search, about relevancy, and of course about the user perspective, because this is crucial to have a good search up and running. You need to think from a user perspective. You can't just run a search and hope that this is what the user wants. Also, talk to your users, understand what they are expecting when they're running a search on your application. And before I joined Elastic, I used to run a B2B marketplace with Elasticsearch as a product search engine, primarily for the German market. And the German language has its, let's say it has its own specialties dealing with certain things and also its own complexities, like any non-English language, I would say. And this means I had to deal with the users, and the users were from a specific group running hotels, running restaurants, and maybe having more of a background as a cook or manager, but not so much from a technology perspective. And those are all things you have to cater for in your own applications. Who is your target group? So, what is the ultimate search experience? Well, I think most of us have kind of a gold standard set already, if I would ask this question. And this is this one, right? That's a Google search. Google search is kind of the ultimate search experience. You go to google.com and all you see is a single search bar answering all your questions magically. And that is great, right? Like you don't have any filters, you don't need to click around. We all remember those fancy forms from the 90s with 25 different fields. You had to put the first name in there, the last name in there, the employer in there, the profession somewhere else, just to search and filter for data. And of course, that was horrible, right? Nowadays, you have this single search bar and every problem is solved. Well, that's what we would like to have, right? And Google has a powerful search syntax. You can filter for date in there, so you can change everything within a single search bar because there's a custom syntax. But of course, if you dig deeper into Google, you will also end up with this, right? Where you can pretty much specify words, exact words or phrases in different forms again. And we are kind of back to the 90s. And because this is Google and you're usually searching something very specific when you go to the advanced search, this works. However, do you expect that on your e-commerce shop, people are using this kind of UI to actually search and try to find things? It's unlikely. Or imagine going to LinkedIn and having those different fields to put in whom you're searching for. Why that works, it's unlikely that users would make use of that. So the more specialized you are, the less you try to have something like an advanced search. For the Google case, this only works because they are really, really broad in what is their search experience. And also we have to figure out the query intent. And this is something where a search like Google with their decades of experience really shines, right? If you search for something like this, the Google query parser and the intent is kind of clear, right? You want to figure out there's a temporal part in this, and then there's an informative part in this. So this means like Google kind of figures out, okay, I know what you searched for. Most of the time, Google nowadays suggests a Wikipedia page. So the intent is rather clear. Or something like this, it's not only numbers, right? It also knows, tomorrow means the day after today. So I probably show the weather forecast up here. So those are all things that, especially imagine your weather search engine or your weather website, then you have to capture this kind of information to just show what you actually want to show and not let the user run into searching for text that contains tomorrow across your website. And this is really important to figure out the query intent of a search request, right? Something like this, if you type this into Google, it will return the current age of Barack Obama. So there's definitely some sort of more than just trying to search for documents that contain these phrases. And there are tons of users who type in the website they want to visit into Google, like Twitter, Facebook, whatever, especially like older users, less experienced users, and they are used to this kind of how the internet works. So this is also something that Google in that case caters for. Or this is a classic e-commerce search request that you basically have to dissect this, right? Because you probably would not find this exact description in a product description of any of your products. And you have to know, like, maybe cheap, you want to only filter on products that are on sale. Then Nike is a brand, so you may want to move this filter over to the brand. And then there's a color inside of that, so you don't want to search in the product description or title, but you want to filter on the color. The same applies for size. So basically, there's only one term left, and even the hoodie term could be like a category or something like that if you're running a clothing e-commerce shop. So understanding this intent and kind of modifying your query in the way is important if you have an experience, if you want to offer an experience where someone's really trying to filter down on a certain information. And the thing here is Google, of course, is Google is extremely generic, right? They kind of cater for any kind of input, and this is really good. And it's rarely needed for most of the web applications that you're running yourself, because usually the web application you run, you write, it's kind of specialized already. Like I ran a B2B e-commerce shop for a certain category of professions like hotels and restaurants. And that makes it kind of easy to at least reduce this whole query intent to something more manageable. And many of those use cases are basically specialized, like e-commerce. We're going to see that in a second. News are kind of specialized. Most people who are searching on the web for news are mostly searching for recent articles, unless there's a date specified, like with the stock crash example. But recency has a huge role in news search engines, because you usually want to show the most recent events rather than something from 50 years back, unless someone is explicitly searching for that. And the same applies for social network search. This is what my demo is basically showing nowadays that I brought with me, where we are searching for contacts, and there's a couple of rules, and we try to infer the set of rules of how LinkedIn is working. Well, let's take a look at e-commerce. This is Amazon. Probably most of us know this website, and there's kind of a journey how the search engine or how the Amazon search is basically used. And it not only involves the search, it kind of starts with the search bar at the top. And you can also see here, this is not like Google. Google just had this one search bar because Google did not really know what you were trying to search for. But Amazon knows very likely that you're trying to buy something. So they can show a lot of things already on their main page, right? You never see Amazon with just a search bar on their main page compared to Google. There are always products, there's always something to lure you into buying. So you can see that this is already the first step of specialization, completely independent from the search. But also the search is different, right? Because when you start the search, the next step you usually do, like I searched for a 50-inch TV here in this example, is that you try to drill down via the faceted navigation left. And this is a component that is absolutely everywhere in e-commerce, right? Pretty much you're usually offering so many different products that people do not try to type something more into their search bar. They do not try to say TV 50-inch between 200 and 400 euro in the search bar. They just want to have this available as a facet, click on it, and know that then there's suddenly a filter based on what they click on. Like common example for Amazon usually is like Prime delivery, or the ratings, or in this case, maybe you're interested just in a special brand, or you want to make sure you exclude a special brand in that case. So, and only after you select those facets, the number of documents on the right, the results have been reduced properly. You usually go down, select the product, and put it in the shopping cart. So you can see here, this is a kind of very defined journey, and usually you also know what you want to buy. So this is kind of how it starts. And this is also part of the ultimate search experience, right? Like, even if you think that you kind of pick the preferences, you made the first search, at every single stage, the search engine can kind of add some flavor to it to answer the question that is maybe also in their commercial interest. Let's take a look what I mean with that. So the first thing is the scoring and the ranking of the product that you just saw. It's never neutral. There are a ton of influencing factors in an e-commerce search. For example, the popularity. If you know that a product is really popular, gets bought a lot, you may want to score it higher. That always comes with a price in e-commerce search, and one of the big prices in there is that the winner takes it all. Because the product is popular, you score it up, it gets bought more, and it stays up in the score. And this may be something that you want to make sure is happening, because then you can only stock your shelves with one single product or a couple of different products, which you need to stock a lot, and the other ones don't need to be stocked so much. But it also means that you probably don't sell other products. So popularity is a used metric, but needs to be handled with care. Profit is another interesting one, right? If you search for iPhone on any e-commerce site, the first thing that pops up is an iPhone leather case compared to the iPhone itself. That's not a good experience unless you searched for iPhone case. But because you would probably make much more money with selling the iPhone, it's very likely that these kind of items will occur first in your search. And the same is with my TV search, right? If an e-commerce handler is making 10% on one product and 20% on the others, it probably scored the one which gives a higher profit higher up in the search results. Availability is a big deal today. Back then, when I was working on that e-commerce engine, we started to factor this in the search. But today, you can pretty much already filter out everything that cannot be shipped immediately, right? Users are expecting immediate availability and not get sent from China and you have to wait unless this is marked explicitly. So if something is available, if something can be sent really fast, and that's also a huge factor at Amazon, for example, it gets scored much higher. Also, previous searches might come into account, right? Like every e-commerce system gathers all the searches together that you did previously, maybe also just in your session. And if it figures out you already marked LG TVs or Samsung TVs in your previous search, maybe score those a little bit higher in the list of products, because you may want to take another look at that. And the same applies for previous purchases. That said, in this example, TVs are probably not a good example because you only need a new one every couple of years probably. But if you have products that need constant buying, that might be a good idea. Imagine you're buying the same diapers over and over again on Amazon, and suddenly Amazon decides to jump into the diapers business. Then they probably score their own products higher. And this is an important trick in that case. And of course, you want to do some cross and upselling products. So this may be embedded in the search, but this also may be embedded in the display, like people who bought also bought. So there are a couple of ways to show this, but this is something that definitely is done in the search experience as well. So let's switch gears a little bit. So we get more to the demo, and let's take a look at LinkedIn search, because this is what I brought for my example as well. It's a small Svelte application which queries Elasticsearch, and I took a look at the LinkedIn search. Like, how is it working? What is it doing? Can we copy the behavior, and what is a generic behavior, right? So when I search for Philip, which is kind of a common German name, I would say, you can see that there's a couple of Philips returned from my LinkedIn contacts. And this firstly implies there's a search for the first name, right? Because there are a couple of Philips with the first name Philip. There's also a search for the last name. You can see that at the third hit, that there's definitely someone with the last name Philip. There's also a prefix search. This is something we can infer as well, because you can write Philip with one P or with two Ps at the end. And if it has two Ps, it's still shown. So it's not just a full term hit. It also is a prefix search where we're searching for people which name starts with this criteria. So this is all things we can infer from the search. And there's another important thing. You can see here that first degree connections are definitely preferred over second degree connections. All the hits displayed here in the search as you type functionality show that the first hit that the hits that are displayed first are always first grade contacts here. So people I already have a connection with. And then there's a second degree user at the end. And we can also infer out of that if the next hit is a second degree user, the LinkedIn search takes this into account as well and makes sure that if you have indirect connections, they are scored higher from a second than the third degree part. So all of this can be inferred by just running a single search. And that's an interesting aspect, right? When you run a search in other search engines, there's a lot of things you can learn how their search is working. And sometimes it makes sense to understand how the search is working if you try to incorporate a similar feature in your system. Sometimes it just makes sense to understand how you should actually execute your search. So if we search for another rather common name in Germany or in Europe, it's Felix. And that name is also interesting here because, again, you can see that there's like 4 direct connections that I have and another second grade connection. But the interesting part is the highest score result here is actually not a direct connection, but it's a second grade connection. And there's Felix is actually the surname. So what does this mean? It means either that a surname is more important than the first name, which I doubt. But given the way how scoring usually works, it's kind of something called TF-IDF, term frequency and inverse document frequency. The reason is that Felix is a really rare surname, which means that it gets scored higher than Felix being a first name, but occurs way more often. That's how searches are working by default. You can, of course, tweak this behavior, but this is what we see here. So we should probably try to take that into our account for our own application. So in order to show an example how to go from a small search where we basically just search for the name or for the surname down to taking those different factors into account for scoring, let's first build this using Elasticsearch. So let's do a quick introduction over here. What Elasticsearch is, you can see it's sitting in the middle in the Elastic stack. Elasticsearch is a search engine. It's based on the Apache Lucene, but it has some more features. We get to that, but the main thing here is it's kind of the heart of the whole stack, right? Kibana is a management and monitoring UI on top, and Beats and Logstitch are ways to index data into Elasticsearch, but because everything is HTTP, you can also just use your own mechanism. And there are basically sort of 3 specialized solutions on top for specific use cases like security, observability, and enterprise search. Enterprise search being those kind of searches in your intranet data if you want. Observability, the classic logs, metrics, and traces use case, but with much more underneath, and security being the security use case for endpoint security and incident event monitoring. Yeah, you can deploy this on different ways, like software as a service or a Kubernetes operator or running it yourself. The interesting part here is for us today only Elasticsearch and Kibana. That's what we're going to take a look at. And Elasticsearch as a search engine allows you to do the good old full text search if you want. Full text search in this case means that you can type in any term and you get back the document that matches the term. This is what we are basically after today. Consider it the Google use case or the AWS use case or the LinkedIn use case. We're not going after analytics today. Analytics could also be seen as some sort of business intelligence if you want. And also things like GeoSearch. Think of the Yelp use case. I'm searching a restaurant, which is 5 minutes by foot, are things that are not covered today, but this is all things that Elasticsearch can do. The whole idea is it's near real time, so the time between indexing and waiting unless something becomes available is as small as possible. And then lastly, we have the ability to run distributed. So Elasticsearch is not bound to a single system. You can also run a cluster of hundreds of nodes. It's highly available and resilient. Of course, the more nodes you have to consider that high availability goes down because not every node is available. But the core idea here is that the cluster is available, not a single node. As a user, you don't care if you query a cluster with a single node or with 100 nodes. You basically just want to make sure it's always available and you can query all your data. And the resiliency part here is supposed to be the ability to recover from failures. If there's a node failure, the cluster detects this automatically, rebalances the data if needed, and you as a system administrator don't need to do anything about that except trying to bring up the old node again. The interface is HTTP and JSON. The reason for that is simple. Developers know HTTP as a protocol. Developers know JSON as an object notation. So both is kind of familiar, which means you still have to deal with the new technology of how to run queries and things like that. But at least there's not another technology burden on top of that. So our sample application today will be the LinkedIn use case, which means we are searching for persons. And they usually have a couple of fields. A person usually has a first name and a last name, which we will search for. So this is important for matching. Then we have scoring. So there are other factors that are important for relevancy. There would be, for example, the employer. That was also a case, like either first grade contacts or employer was kind of important in the LinkedIn use case, or being a direct contact, or being both. And of course, there's a couple of meta information like the title of a person or the image, things like that, which are not important for matching, which are not important for scoring, but are still part of the whole entity. So the way this looks is like this. We have a name field with first and last name. We will also enrich this with a full name so that you can search in just a single field. There's an employer, there's a title, there's an image, which would just be a reference to a PNG. And then there's the list of other contacts. So whenever we accept a contact, this list of contacts would just be expanded. Same for the people, for the person who received this request. So in this example, Philip K will have me as a contact, and I will have Philip K as a contact, and this for all the others as well. So those are basically the IDs of the other contacts. So I would say we can start the demo. Let's quickly, if you want to rebuild this, you can just clone the GitHub repository, run npm install, create a static build so it doesn't do live reload, or you can change the small Svelte application and have live reload as well. You need to install Elasticsearch. The current up-to-date version is Elasticsearch 7.9.3. You can just download it, you can unzip it or unpack it. It's a TGZ archive and start it. You don't need to install anything else. Elasticsearch ships with a JDK so that you don't have to have any external dependency. It's really just downloading the artifact for your operating system, and that's it. The same applies to Kibana. You don't really need Kibana to get the application up and running, but Kibana is the kind of management and monitoring tool that we will also use to just get an overview of how things are basically working. All right, this is the sample application. Let's take a look at that in the application itself. So if we go over here, I basically, let me full screen that. So I wrote a small Svelte application that basically displays this kind of social network. There's an admin interface, which allows us to reindex all of the data. You also need to enable for your Elasticsearch instance this cross-origin resource sharing if you want to make this work. So I did a shortcut here. I'm directly querying Elasticsearch from the browser. This is something you should never do in production, but my main course here to show you is to show the queries. So I try to keep the complexity of the application as small as possible. And in this example, you can watch your own profile. This is myself. You can see your contacts. So this user has 3 different contacts. Surprisingly, all have very similar names. It's just to make the searches work later on. And the last part is basically running a search. All of those 3 pages have a search running in the background, and we're going to take a look at those as well. And then we can search for users here. So I can run a search for Philip or Philip with double P and get different records. You see that there's a score. We're going to talk about the score in a second. There's also different coloring for the border here. If it's a red color, that means it's a direct contact. If it's not a red color, it's not a direct contact. You can also see here that all of those first 3 hits, they basically have the same score because they all include Philip, and the length of the field in terms of the number of terms is the same. But the interesting part is here, we can now take a look at those queries. And this means we can take a look at the queries of how they work. And this is kind of the most simple query. We are just searching in the first name. So this also means if I would search for this first name, we would not get any result because it's not a first name. So this means we kind of need to tweak the query now step by step, right? We could run this query and hope that the users are finding what they're searching for. I would probably be a little bit naive. So the first thing we do here is that we're scoring our own contacts higher. And that works with something called a terms lookup. So now we have to already dive a little bit deeper into how full text search works. So we do have a bool query here, and that is a should clause. And this is something that is very different from other data stores because in search, everything is about relevancy. And this means that you can score things higher based on other criteria. So you can make a document more relevant instead of just excluding or including it. So what happens here is we are still retrieving all the documents with the first name of Philip with a double P at the end. But if it's part of the contacts field, so the list, the array list of all the contacts of these users, it should be scored higher. And this means we already follow like the first approach of improving our search. And if you take a look at the bottom, there's a red border around those 2 cards, which means those are my direct contacts, and they are suddenly scored higher than the other contacts. And this is the first way how we can basically change or tweak the relevancy without changing the number of results. It's really just about the order of the results that are being returned. So the next step is probably that we want to score the first and the last name. So we can just search for Ukraine being a last name here, or Laughable with another one. And score for that as well. I can also search for first name and last name in combination. As you can see here, there's only required one of the two terms is only required to match. And we are also searching either in the first or in the last name. As you can see here, suddenly a user comes up that is not a direct contact, but has Philip in the last name. And that one in this example also gets a higher score because Philip as a last name is more rare than Philip in the first name. So we could go further here and score with the first name and last name, score the own contacts and the colleagues higher. What basically happens here is that we do have a should clause, and a should clause as well as a must clause. Must is something that has to match. Should is something that increases the score or the relevancy. You can have several criteria. So in this example, if someone works at the same employer than me, and is part of my social network, this person is scored higher. So we can just search for Philip again. And you see here that this person who is a first contact, works at the same company than I do, has the highest score. This is a contact as well. But interesting enough, this other person with a surname still gets scored higher. And this is where scoring suddenly gets tricky, right? We could now try to optimize for the single use case that all my contacts should always occur up. But of course, this has other effects if you really want. And this means that you have to test and to tweak a lot with these kind of searches to figure out what is the best way to improve things. And we could go further here and again change our query. And you can see here I added a boost. And the boost in this example means that the first and the last name, the search itself is considered more important than the should clauses. So even if someone is a contact, even if someone is a colleague of mine, we still want to make sure that the full text search match here is considered twice as important than it was before. And we would end up with the person with Philip having the surname up in our scores. So as you can see here, we now added another field. So we can search in the full name field. So we will search for Philip Cran, and we can see here that Philip Cran is just a single contact in this case. However, there's still one thing missing. All right, now with this, we fixed a lot more. Sorry, I mixed up the search. I switched the field where I'm searching, and I switched it to a dedicated field named search as you type. So in order to understand this, we will go to Elasticsearch in a second and take a look at the configuration. But the search as you type functionality really allows me to say what it says, that it's not only searching for full names, like a Kren in this example with a double N, but it's a prefix search. So this means that I can kind of search for and you suddenly get every Philip in this example. Or I search for Philip and I get suggestions or search results for Philip Kran. So with this way, you can execute a search while you type. Be careful with this kind of functionality because you're sending a lot of search requests, which is from a performance perspective usually not a problem. But you also have to make sure that your users are actually seeing this. So we did user tests at my previous employer, and because the target group was not like technology persons, they were mainly watching on their keyboard while they were typing. So they didn't get any feedback of this kind of suggestions and didn't select anything until they finished typing. Nowadays, things are even different because on our phone, our behavior is very different, right? It's not only about suggestions, it's also about typos. Like when I type something in my phone, I'm usually fat fingering around and I have a hard time probably typing the correct word without any mistake. And this needs to be taken into account as well if you run a search. So just keep that in mind. And here's a last change, that if I run a search, I also want to make sure that I can turn or flip the terms around, right? When I run something like a social network, maybe people are trying to search for the last name first because they remember the last name and not the first name. So this is something you also have to take into account when you create this kind of searches. And to take a step back and take a look at the configuration, let me make this much bigger and it's easier to read. We're not going to take a look at the different queries. The different queries are in the application. I'm going to show that in a second. But what we basically have here is we have created an index called social network. And this index contains our users. I only have a test index of, I think, 10 users or something. But it also contains the configuration for every single field, right? If you take the name field, for example, which is over here, you can see that there are different subfield. There's a search as you type configuration, which supports this prefix type functionality. There's also text fields, so you can do the regular searches that we saw at the beginning, and we did the similar for the first and last name. There's the contacts in there. So the contacts are a list of people that I'm connected with. So if we run get social network .lxr, that's the user I'm supposed to be logged in with in the sample application. You can see here, there's my first name, last name field, and down at the bottom, there are the contacts that I'm connected with. And those are the ones which are basically scored higher. Why? We have this terms filter here. And this one is basically looking up the contacts. So it's querying or it's retrieving the data that I'm showing here, looking up the contacts field, extracting this array, and using this to score the contacts higher. So if I add a new contact, and that one is called Philip X or something like that, it gets appended to this list. And this query doesn't need to change. We can just run the same query, and the new contact would already be scored higher without any change. So it's a little bit dynamic. It just needs to look up these contacts before executing any query. So there's another step basically that needs to be taken. But this way we can kind of do this sort of scoring. And as you can see, and this is one of the main points I wanted to say, you can start with a small query, which is just like this at the beginning, right? The simple query that you saw. And it's really small, it's compact, it may be sufficient for exploring, But the moment you think about how your users are handling your application, will be the moment where your user, or where you as a developer of the search application, usually end up with more complex queries. And this is fine, right? As long as the query is answering the question that you actually had, there's no need to really be worried about your query being too complex. Like, as long as it's within your SLA in terms of speed, as long as your users are happy and consider the search results valid, this is all fine. And like, just sit down and come up with ideas how to improve your query. Think about relevancy and what it means. So, yeah, for time reasons, I would just send a link to my presentation later and include these kind of links. So this is just an example that you can use as well. There's enough information to basically get up and running. But I'm going to jump back to the presentation now. I have a couple of slides left. Yeah, this is just to repeat, like, this demo is not supposed to be run anywhere on the internet, just run it on localhost. If you would like to run it on the internet, you would need to have some sort of middleware where you basically send the search to. That is also responsible for indexing the data. Everything here is done right from the browser, and this is not how you should be using Elasticsearch. All right, let's do a quick summary because we're running at the end of the time already. So coming up with a simple query is easy. You just thought, right? Elasticsearch has a ton of functionality to really come far with simple queries. You can select multiple fields, like searching in the first and last name fields from the beginning. All of this is good. All of this is easy. But the next step you always have to do is figuring out user intents. This also means you have to kind of know what your users are searching for. So logging their queries and analyzing those actually makes a ton of sense. And after doing that, you can also think about not only logging the queries, but also figuring out in the UI, like, did they really click on the first result? Did they paginate through the 10th page, which usually means that they did not find what they were searching for, to mix and match and understand what the user is trying to do. And of course, talking to your users is a good idea as well most of the time. So yeah, coming up with a proper query is nothing that like happens immediately. So taking a look at the Elasticsearch reference documentation in the Elasticsearch case and just trying to figure out, like, what do I search for? What kind of different queries exist? How do these queries behave if there's certain data being indexed? It's really, really important and highly encouraged at that stage, at that point. And just as I mentioned, analytics and metrics are vital, right? If you just have queries and users querying your search engine, it's going to be really, really hard to figure out, like, what was my user's intent? Was the user intent satisfied? Of course, if you're an e-commerce shop, you have sort of secondary metrics deciding about that. Think about the conversion rate. If you improve your search and your conversion rate goes up 0.5%, you have a direct link. If you did 25 other changes in between as well, the link gets much harder, of course. But at least there's a link that can be connected. So there's second order metrics, but if you have direct metrics and analytics about your search, like, did this search lead to a product view? Did this search lead to putting something in your shopping cart? I think you can create like much better indicators if your search has improved or not. So this was really just a small introduction also about the capability of Elasticsearch. There are more advanced features that you could take a look, like the rank feature, field type, and query type, for example. I didn't talk about that, but that one is extremely interesting because you can score based on the numeric value of the document. So imagine that you have within the document your profit gains, like you get a 10% commission for that, you get a 20% commission for that product. You may want to boost this based on your commission so that you increase your commission based on your search results that are being ranked. This is something that would work with rank feature. There's also a vector field type that allows you to do similarity search based on a feature vector. So you kind of decide what features you want to use. You encode those features in numbers. And then this query will basically run a couple of different similarities. By default, it's a cosine similarity, I think. And you can use that to find similar products or similar behaviors of users if you want. All right, I only have like 3 last sentences that I want to give everyone back home to just think about how you can set up your search, configure it completely independent from your search engine. But the one thing I always ask yourself, like, if you have a search bar, can you quantify the search experience? Can you say that this is good or bad on a rating from 1 to 10? Do you know that you have an excellent search, that the users are really, really happy, or not? Can you measure search improvements in your infrastructure? If you change your search, if you come up with a new fancy query really long that you think it's really good, like, can you measure that the users are actually having the same experience that you had with your test data, with the live data that they are searching for, with the searches that they are executing? And do you have a continuous feedback loop? Like, do you kind of take the information that you have from your metrics and analytics part, and are you using this to improve your search? Do you change the boosting? Do you change the importance of a search or of a should clause? Do you make the employer much more important than being a direct hit because your users are always searching for their employees on the website, like on LinkedIn? Do you have this kind of feedback loop to incorporate this information back in your search? That's also an important and crucial question to me. All right, that's it. I pretty much finished, hopefully on time at this stage. If there are questions, I'm super happy to answer them. I will publish the slides later on. I tweet about them. They contain the sample repository that you can try out if you want. I will also refer a little bit to the documentation if you want to know more about certain features. Of course, there's meetups regarding the Elastic Stack if you're interested in that, and Discuss forum. But yeah, for now, I'm happy to answer any question you got. And thanks a lot for having me today. And I hope you enjoy the rest of the day for the conference.
Alexander, thank you very much for your presentation. It was amazing.
Thank you.
I have one question to you before you continue with the Q&A session. So if you could have one advice to software developers for 2021, what would that be?
So me being biased as a search person is obviously that something like search will completely permeate to many, many more applications that we see right now. And I think this trend will continue. And search is much more than the full text search, right? Like, many people are using Elasticsearch for things like logging and observability. And the existence of search is something which will not go away, but users are expecting really good experiences. And from my perspective, and that's not only for search, but also for anything that we developer, think of the users and think of the users first. Like, that's my number one advice. It may not be the newest one, but it also doesn't age.
Fantastic. Thank you very much. I'm inviting you to the Q&A sessions together with our participants who watched your talk. So you can meet your followers at Q&A session. I'm inviting you right now. Have a great day. Thank you for joining us. And I hope that you will come to Kyiv next year and we will meet in person.
Looking forward to that. Thank you.
Thank you very much. Have a great day.
Goodbye.
Bye-bye.